I do want to talk about that homework a little bit, so let's do it. Homework should be out. I want to talk about trouble. Swap out this battery. I can feel it. It's like on the verge. That makes sense. You did that was 5. Some of them could have been 5. Alright, party time. So, 4.2 is pretty critical. Then we will take a break tomorrow. We will take a break and just exclusively do Halloween stuff. Okay, Monday is also a little bit wonky with the half day. Okay, so we won't have 4.3 for a little while. This one is pretty crucial though. Okay, so we gotta make sure we get everything in. Okay, I want to focus just on a couple things from the assignment last night. Okay, I'm not sure if you're aware, but you know, even though they didn't provide you with all of them, you can get internal angle measures. I briefly talked about that, but you didn't need to know all of them. All you had to do is decide who corresponds with who. Okay, so 1 corresponds with 110, 2 corresponds with 120. You don't need to show any more work than that. You just need to know who corresponds with who. Okay, so hopefully that wasn't too much of any kind of issue. Okay, anytime they ask, can you conclude the triangles are congruent? Okay, I mean, if it's a no, you can pretty much tell me no. I mean, I don't need to really know why you can't. You can say you're missing a bunch of information. But if you are going to say yes, this first guy's a yes, you do have to tell me how you know the things that you know. So what are you given? This side, these sides. You need 3 sets. How do you get the third side, everybody? Just say reflexive. So that's what gives you that. So I had to say reflexive. Okay, you have 1 angle, 2 angle. How do you get the third one? Third angle. Okay, cool. If it's a no, you can just tell me no. You can say you're missing too much information. Yada yada yada. Okay. How did the fill-in proof go? Is that okay? You're allowed to abbreviate congruent triangles just like I did. Definition, congruent triangles. You can abbreviate third angle theorem. Yada yada yada. I don't really worry about the algebra too much. Number 13 is sneaky though. Did anybody think they were triangles or not?
No.
Okay, so no one actually thought that those were triangles?
Only because they have like an angle.
I know, but okay, fine. Not one person here, quick glance, thought they were triangles. Okay, thank you. I thought at least one person. Okay, you're all apparently so smart. You knew immediately they weren't trying to trick you. Okay, cool. I want to talk about 14. Now, if you checked with my answers, I did a 7-step proof. Some of these things could have been combined. You can't combine too much, but I decided to break down, this is only because it's been a while. BD is the angle bisector of ABC. Your diagram was unmarked, correct?
Yeah.
I would really consider marking the diagram as you go. That's not required. When I'm grading your proofs, I'm only going to grade the proof. But I think you should mark the diagram as you go so you know what information you have and you know what you have left to go. What I decided to do, I was going to split bisector and perpendicular bisector. I don't know if anybody noticed. But a perpendicular bisector, it doesn't do one thing, it does 2 things. What does it do? You should know this. It draws a line that makes perpendicular angles, and it also splits it into 2. So I'm looking at my proof. My proof was 7 steps. I think you could have done it in 5. Okay, did anybody manage to get it done in 5? 1 person, 2 people. What you probably did was, I'm guessing, you did more of a perpendicular bisector together. Okay, so that's okay. I do want to talk about the proof though. What was the whole essence of yesterday? To prove the triangle's congruent, we need 3 sides that match each other that are congruent, and we need 3 angles that match each other that are congruent. You are given a lot of information, okay, but you still have to finish the proof. So what are we given? Okay, we're given BD is the angle bisector of ABC, so boom, right there. BD is the perpendicular bisector of AC. That actually gives you a lot of information. That gives you not only do they make right angles, that gives you these, okay? So I marked the diagram, I put all of my givens in. The first thing I noticed was AD is congruent to DC, by definition a bisector. But I could have lumped that in with perpendicular bisector. Okay, so that gave me these sides. So now I've got those, I've got those. How do I get the third? We've been doing this for like a day now. Reflexive, okay? Let's talk angles now, okay? Well, if it's a perpendicular bisector, that creates those right angles. I want to highlight this because you're going to get sick of this, but I don't really care. You have to declare things right angles, and then, this is a theorem that we talked about a long time ago, okay? All right angles are congruent. You cannot just say they're right angles and leave out the all right angles are congruent step. You're going to get tired of it, but you also now know it's coming. So be aware. If you have right angles, you can't just leave them right angles. Why are they right angles? Because we know what perpendicular means. We have to state that the angles are congruent. Your reason can always be all right angles are congruent. You can always just say that. If you can't remember if it's a theorem or postulate, just state all right angles are congruent. Okay, so I've got these because of the angle bisector. I've got these because all right angles are congruent. The only angles I did not have given were A and C. I could use third angle theorem for that if I wanted. Okay, then the triangles are congruent. Okay, but this right here, you're going to see it, you're going to get annoyed with it, but you have to do it. You can't just leave things right angles. You have to declare them right angles and then state all right angles are congruent. Okay, cool. Okay, let's go to 4.2. 4.2 is a lot. We can still get done. Yeah, go ahead. 4.2 is a lot, but we can make it work. Okay. So this word included is highlighted quite a bit. Okay? And I don't think you're going to get these wrong, so I just want you to fill in those 4 blanks, just you. Okay? With no other information from me. Fill in those 4 blanks. 2 of them are included angles, 2 of them are included sides. And these are not trick questions. If you're like, I think this is obvious, I'll bet you'll get it right. But I'm just going to pick people, so hopefully you're okay with that. All right. Let's go, Ryan. Included angle between AB and CA, what'd you say? How many of you said angle A? Yeah? Now you could say like CAB, don't do that. Just call it angle A. There's a little hint in here, I don't know if anybody noticed. Do you see how they share A? Shouldn't shock you. So between AB and CA, there's angle A, okay? Caleb, how about the included side between angle A and angle C?
Line segment AC.
Thank you for saying line segment AC. Good job. Okay, line segment AC. Prisha, included angle between BC and CA. Cool. And let's go, Ava. Included side between angle B and angle C.
Line segment CD.
BC, CB. In that case, the order does not necessarily matter, which is good. Now, the picture helps. Could you get it without the picture? Sure. What if I gave it to you without the picture? You could just sketch it if you needed to, okay? When we say included, you should know that there's included angles and then there's non-included angles. So look at the first one. AB and CA is angle A. That's the included angle. How many non-included angles do you see? 2. Okay, good. That's going to come up quite a bit. Okay? Good times. I think we know what a postulate is, so we can kind of skip right past, okay? Now, they want us to build these triangles with polystrips. Like, I won't lie to you. I don't have enough. Did you ever build anything with polystrips as a kid? Oh, sad. You missed out, okay? They're just these little plastic things, and you can build triangles. And you use paper fasteners. Have you even used a paper fastener?
Yeah.
Oh, you have? Okay. You build little, like, rigid triangles, and then you go. So they thought about having us build with polystrips. I don't have enough for you, so sadly you missed out. Maybe one day. Maybe I can find some more, okay? But in general, they wanted us to build a bunch of triangles with polystrips. This is just going to be sad because we don't have enough polystrips, so just put sad face. We don't need to do it, but maybe one day I'll have enough that we can all do it. Or I can have like a station where you get to come up. Okay? So we are going to jump right into our postulates. Okay, this is one of the big sections of chapter 4. 4.2 and 4.3 are like pretty big in terms of what you'll do for like the rest of the course. I figured we could just dive right into the postulates. Reminder, what's a postulate? We don't have to. Good. In fact, a lot of times it can't be proven. It's just true. And you're going to look at this first one. You're going to be like, duh, but we need to know it. It is called the side postulate. Okay, yes, you're going to want to abbreviate that. How do you think you abbreviate it? SSS, okay? So, what is the side postulate? If 3 sides of one triangle are congruent to 3 sides of another, then the 2 triangles are congruent. We don't even need to talk about the angles. In fact, sometimes you're not given the angles. But stands reason to believe if all 3 sides are congruent, and we look across, then the triangles themselves are congruent. What are we doing? Come on. So there's 2 examples on the board. The blue triangle and the magenta triangle, they're congruent. We don't even know anything about their angles. We don't care. 1, 2, 3 sets of congruent sides. They're congruent. And for our reason, if we were writing a proof, guess what your reason would be? You don't even have to write the word postulate. I will let you just write side, SSS. Okay? You're going to want to because you're going to be writing enough. Okay? They're claiming triangle NQY is congruent to triangle PQY. Is it true?
Yes.
Yes, because what do I know? Reflexive, therefore they're congruent. I'd have to state reflexive, and then my reason is side. So you do not need to write the word postulate at the end. You can, you don't need to. Okay? The angles don't matter at this point. Side. I mean, just think about the logic behind it. If you have 2 triangles and they have the same exact sets of sides, they're congruent to each other. The angles kind of follow along. Okay? So I'm actually going to do a proof using side. I want to see if you can do it on your own. Okay, or together. So go ahead and see if you can complete that proof right there using side. What? Go ahead, my goodness. Look at your givens, look what you're being asked to prove. It's just a little baby 3-step proof. Little baby. Just a baby. If you were paying attention to the one we just did or the conversations we just had, you should be like, wait, this is very similar. It is very similar. Quick compare with somebody around you. What did you list as your first step, second step, third step? And all right, now if you have good eyes, you can actually, can you see? Yeah, I actually can too. Okay. So, what should go into number 1, Sari, statements?
P1 PN is congruent to 1 LN and 1 LP is congruent to 1 MN.
Reason? Cool. We are 2/3 of the way there. Colin, what's our next statement?
I said, what's the problem?
No, I want the statement.
N is equal to N. NL is congruent to N.
Okay, Ln is congruent to Ln, or NL is congruent to NL. Reason, reflexive property, congruence. This is where, now a problem like this, most of you won't do it. Fine. They're going to get more involved. So before I went to step 3, do you know what I would do before I go on to step 3? I would mark the diagram. Again, I'm never going to make you do it. You can get it right without it, but these proofs get a lot more complicated. Think about that homework problem we just went over. You should consider marking the diagram. Because this proof is done, they're going to be a little bit more involved, okay? So now I know what I have. Do I have all 3 sides? Benji, what's next?
triangle LPN is congruent to triangle MLM, and that's SSS.
What's the reason?
SSS. Side.
Beautiful. I think it's a success. SSS. We're good. Oh, we're not good. Ah, good job. Again, somebody in period 5 said it's like you say like amen at the end of your prayer. Good job. Make sure you say it at the end. Otherwise, you're not done. How do you know when you're done? Okay? SSS is good. Okay? Cool. Now, this one's a little bit, I don't want to say trickier, but it's a little bit more specific. Side angle side, which we will abbreviate SAS or SAS. Sure, you can call SAS if you want. I'm fine with that. Okay? If two sides and, now here's the thing. It's not just any angle. I want you to look at the diagram I have right there. Two sides in the, think about what we just did. Flip back, Cole. Casey, thank you. That's why we did the included stuff. If you said it, say it louder. The included angle. It can't just be any angle of one triangle are congruent to two sides in the included angle of another triangle, then the two triangles are congruent. Again, this is a postulate. It is accepted proof. But it has to be the included angle. So that's why I showed you this diagram. So I like these as congruent marks. You might not see these again, but that's like the diamonds. Like, look at that. That's fun. Okay. So those are congruent. Those are congruent. The angle in between. That's what we mean by the included one. It would not work if instead of this angle, they gave me like these angles. That would not be able to determine that the triangles are congruent. So it has to be side angle side or fine SAS. I don't care. But it's one SAS. SAS, not SASS. It has to be the included angle, okay? So, I want you to look at, I think there's two of them, kind of like yesterday. What information would you need to determine that these triangles were congruent? Okay, so I have a conversation with somebody. What other information would I need to prove these two triangles congruent? And then same thing here. The second one we're going to talk about a good bit. First one's not too bad. The second one, we'll talk about why it's a little weird. Yes? No. Good question, though. I get asked that. Can't add other points. You can't add things to the diagram. Yeah, we'll talk about the second one. Don't worry. It's a little wonky. Just the top two, just this guy and this guy, because I want to talk about this one a little bit.
This one, even
that DC is
Wait, no.
Okay, now, I don't want you going too far, not because you can't handle some of this stuff, but I need to really talk about this one because this is going to be such a big thing in chapter 4. This guy's called overlapping triangles. Some of you will be fine with it. Some of you are going to hate the overlapping triangles. That's why I want to spend time. Let's go back to this one. I can tell some of you are, Ava, you already don't like it, do you? The overlapping triangles. Anybody else not like the overlapping triangles? All right, well, they're coming. Anyway, let's go to this guy. So I want to know, what other information do you need to prove triangle ABC? So this is triangle ABC. congruent to triangle CDA. Okay? There's actually only one piece of information that you need true in order to do it based on the way we've been doing it. Cole?
We have to make line segment C be 8.
Not necessarily. Sawyer?
We have to figure out if line segment C is congruent to line segment B.
Sure. Okay, that was just said. So that's not the one we're targeting right now. We can talk about that one later. Layla? Angle what? But this is angle D, and this is angle B, and I don't quite know that just yet. So that doesn't help me. Okay, Jazzy? Angle what?
Angle DAC. No, wait. Angle DCA and angle CAD.
Okay. So here's the thing about 8. I'm not saying that that we're not going to talk about 8. I'm saying we don't really have much about 8 right now, but we definitely have, yes, our favorite, go ahead and say it, included sides. What are they? Let's go with what we have already, and then we could talk about what would be great, okay? We already have this 7 and that 7, and why do we have the 6 in both of them? Because it's shared, because it's reflexive. So currently, okay, now we can talk about side, side, side in a moment. Let's attack side, angle, side first. And if angle, she said it, let's write this one down first. Angle DCA, now we gotta get the right one. DCA is the included one. Who's the included angle in the other triangle? Good. Then we could use side, angle, side, okay? Now, the second one, it would be great if BC is 8, we could use side, side, side. I'm not going to say that that's wrong. I'm going to say that might be harder for us to get to, that this at least gives us side, angle, side. So they're both right. I would look at this one though. I can't have you missing this one. Okay, the side, angle, side is the good one. 6 is shared. 7 is given. Going with our given information, it would be great if the one in between was good, and it is. Okay. Now, we don't know any of this to be true. We're not saying they are congruent. We can't finish the problem. We're saying it would be lovely if we had this, then we could use this. Just like we're saying it would be lovely if we had this, then we could use this. We can't do any of it. Okay. Now this one, here's why the overlapping triangles are going to be a pain. The problems get a lot more involved as the weeks progress, and the best of us can get just a little bit cross-eyed. So, what I would like for you to do right now, I don't care what your comfort level is, I want to redraw the triangles that they're interested in. You're going to get asked to do this in Chapter 4 anyway. Which triangles are they interested in? Because there's actually a lot. How many triangles do you actually see on the board? 1, 2, 3, 4, 5 is the winner. That's a lot of triangles. So let's draw the ones they're interested in. Who are they interested in? Okay, so let's do our best ADC. That's not bad. And then who's the other one? BCD. Oh, buffalo chicken dip for anybody, yes? Anybody else, you like BCD? I love BCD. Okay. So ADC, BCD, those are the ones we're interested in, right? Let's mark on our new diagram. This is going to help a lot of you when we get into like hardcore proofs. What are we given? We're only given what? That's gibberish. AD is congruent to DC. Okay? That's it. What could we use?
The reflexive property of target DC.
Okay, so we definitely need DC is congruent to DC because of reflexive property. Okay, and if we had that, that would give us that. And then what angles would be lovely to have here? Angle D is congruent to angle C, and then that would give us our side angle side. So the problem is not that complicated. In fact, I bet a lot of you are able to see it. I need you to get on board with, okay, if I have to redraw the overlapping triangles, I'm going to do it, because it gets messy. It gets messy very, very fast. Okay. In fact, I didn't even hear all of you say there were 5 triangles. I think some of you only saw 3. There are 5 triangles. There's this guy, that guy, that guy. Now, there's no labeled intersection point, but the triangle's still there. Okay? Cool. Okay, so now I want you to make some decisions here. Can you prove the triangle's congruent? If so, would it be SSS or SAS? Given information only. Stand up when you've made all of your choices. There's 4 of them. Alright, cool, sit down. Thumb up if you can do it, thumb down if you can't. I'm going to want to know what the reasoning is. I'm also going to want to know if there's more than one way, which there might be. Okay? Thumb up, thumb down for the first one. Reason? Wait. I heard SSS, and then I heard somebody start it with A. Can't be either of those. What is it actually?
SAS.
Okay, good. Yeah, side angles. SAS. Okay. Yikes. Okay. There are other ones that we're not going to get to today, but still. Okay. Second one, thumbs up, thumbs down. Ooh, pretty good. Why is it no? They gave me 2 sides and they gave me an angle. You can raise your hand and tell me why is it no? Cora.
It's not an included angle on the second.
It is on one of them, but right on the second one, it is not. So this side matches this side. These angles match. Okay, but then this side matches that. They're not included. This angle is not included between 1 and 2. Probably isn't an accurate diagram. No way we can conclude they're congruent. Okay? Third one. Thumb up, thumb down. That's supposed to be easy. Piece of cake. Yes. Only reason? SSSS. Okay. Now, I know pretty much all of you for the last one said yes, SSS, but I also need you to say or SAS. And can somebody raise their hand and tell us how could you use SAS here? Jazzy. Vertical angles. I could use SAS or I could use SSS. Vertical angles are always going to be there for you. Okay? They're always going to be there to help you in those sticky situations. Okay? Cool. Okay. Now, what I want you to do, I think you're ready to try a couple of these things a little bit more on your own, but I want to see how the proofs go. So I want you to decide, as a group, can you prove that triangle dog is congruent to triangle cat? Okay, can you prove from the information given that triangle AEB is congruent to triangle DBC? Okay, and then there are 2 hardcore proofs at the bottom. So these 2 are just, can you conclude, yes or no? Okay, then there are 2 full proofs. I think you're ready to try those proofs and then we can clean them up a little bit. Okay, so take the rest of them as a group. Let's see how you do. Come on. What did we say for dog and cat?
No.
Why not?
Because one of them's not included.
The angle's not included for triangle cat. Cats would be a little bit different. Okay, you can't use side on the side. What about triangle AEB and BCD? I got this. I got the vertical angle. Yes? No? No, same thing. It's not included. Good. Okay, so now I want you to work on the two hardcore proofs. They are two column proofs. I'm going to have you try both of them. They're not egregiously long. I want to see what you're doing with them. You're doing triangle hot and triangle rod. Hot rod. SAT. There's no SAT. Side angle line. Wow.
Never see that.
Now you understand why. How many steps was the hot rod proof? Anybody figured out? Should be 3 steps. Anything more than 3 is excessive. Anything under 3 is not complete. Okay. Most of you are working the second proof, which is good. We'll clean them up. We'll be all good. Second one sneakier. Doable. That was that line. That was not even, that one might be one of the worst lines I've ever seen. Yeah, that's. You're focused on that I know, but I think they're going to be conservative. I think it's going to be close. That's the problem. I don't think 2 ever plays well back-to-back weeks anymore. That's the problem.
I think it's the CTE.
Basically. Wait, first step is given.
So what I would do is I would combine up these one step and then make your first step. Then the rest is good. What's up?
I swapped yours with the things around. I said that angle ACB is congruent to angle DCE, and then after that, I said segment BC.
The only thing you get by second
BC, sorry, BC.
All right. Let's start with the hot rod proof. The hot rod proof is actually not bad. Most of you kind of cruised right through it. That being said, We need to do it well. There's a little subtle part to the second one, but we'll get to. Okay? I got asked, hey, if you don't know, ask. Okay? I was asked, do these markings mean that they're given? I mean, I know you might be like, duh. Well, guess what? They didn't actually write down given. So I would ask if you weren't sure. The answer to the question? Yes. Okay? They're giving these to you. So who can tell me step one? What are my givens? Grace, what are my givens?
Segment TO is congruent to segment OB, and segment HO is congruent to segment OR.
Cool. Okay, or as I have them here, to do. That proof is a little different because I didn't write out the givens for you. You had to look, but those are your givens. Okay, cool. Do I have any chance at side here? No, there's just no way I can get these congruent to each other. Okay, there's no way. So I gotta be targeting side angle side. I bet I can get there. Sarah, what's next?
Angle TOA is congruent to angle DOR is vertical angle.
Good. I went with hot and rod, but still, I don't know why we're talking back there. I need to move somebody again. It's not hard. In that space. Same angles, vertical angle theorem. Again, most of you won't do this because you're like, it's extra, but it's going to help you in the long run. I would just mark the diagram. It's not hard. And as these progress, then you can at least look at what you have. Oh, can I get the triangles congruent now? Reason? Good job. Oh, bless you. Good. Okay, a lot of you did a great job with that proof. That was not supposed to be tough. Now this one, like T-O-U-G-H, not T-U-F-F, okay? Now this one is a little bit different because when you look at the diagram, nothing is marked, but there is information provided for you, okay? You're given AE and BD bisect each other. It would be really helpful if you knew what that meant, which most of you do. What does it mean? Laura. It cuts them, well, I don't want to say cut in half, but it also cuts them to congruent segments, okay? So good. Now, it's up to you. If you want to mark the diagram now, that's fine, okay? In fact, a lot of people will do that. Once they see this information, they'll mark it. I like to write it down first, okay? You do have to write down that they bisect each other. I know that sounds silly, but it is given information. You have to write down AE and BD bisect each other. If you just wrote bisect like I did, that's fine. I get it. You're already writing a lot. Okay, it's part of it. This is where some of you will get stuck, okay, because you need to decide what does it give me and what is the reason. So if AE and BD bisect each other, let's go to the diagram. What does that give me? Ava.
AE is congruent to BD. AC is
Wait, AE is congruent to BD?
or no. AC is
There you go.
congruent to CE.
There you go.
And BC is congruent to CD.
Correct? Okay, so I use the diagram to get that information. That's her statement. Ava, what is the reason? Because a lot of people don't know the reason sometimes.
Definition of bisector.
Good. Now you should say segment bisector. If you just wrote bisector, I'll take it. AC is congruent to CE. Okay, my congruent symbol got washed away. BC is congruent to DC. Okay, when I change fonts, then sometimes little things happen. Okay, definition of segment bisector. We have two sides. Same question as earlier. Do we have any shot at side? No, but you're starting to see trends here. Okay, what's next? It should be vertical angles. What do we have? Angle ACB. Ooh, is congruent to angle ECD or DCE, whatever. Vertical angles theorem. Bada bing, bada boom. SASSSS. Triangle ABC congruent to triangle EDC. QE. Okay, question. No, great question. Ha! That's a good question that you want to listen to the answer to. Or don't. He asked, can you say definition of vertical angles? You can't because the definition does not tell you that they are congruent. The definition of vertical angles, a lot of you actually got this wrong on one of your first tests. They're angles that are formed by intersecting lines or rays that share that common vertex. So no, you can't. You got to say that vertical angles are congruent. Vertical angle theory. It's a good question. Yes? 1 second. Okay. Cool. Please start looking at this. Okay, we're not going to pick up that. We're going to pick up with these things next week. They gotta stay somewhat fresh. Somewhat fresh. Yes. Why? Oh, yeah, obviously.
No, we have like.
Yeah, just check. It's just
I never know.
It's just estimates for us to check it. Yeah.
I think the last one.